can hear your voice as well, so you can start.
Okay, so I start, and thank you so much for having me today to give you a deep introduction into the 5G radio access network evolution. So just a couple of words about me for the people who haven't heard you.
David, can you just keep your mic close to your mouth? Yeah.
Okay, can you hear me better now?
Yeah, that's much better, yeah.
Okay, great. So I have been in the ICT industry for about, say, 25 years. And most of the time, I've been serving at Nokia for about 15 years and 10 plus years at Huawei. But also I've been always active as an academic, and there you may see the list of university I've been working with. And my area of expertise is especially on the subject I mentioned on the first bullet, so the future wireless, future networks, cybersecurity, artificial intelligence, meaning all applications of 5G, so AI to 5G systems and services running on top, the Internet of Things, and multimedia technology. So today, I have the pleasure of presenting a really comprehensive view of what a 5G radio access is, how it will evolve, and in particular, I will give you real concrete cases so that you may see how this technology is currently used and will be used, as I'm presenting a clear vision of 2025. So I'd like to start this lecture by covering the global 5G landscape, and I have prepared a couple of slides just to give you an idea that 5G is really on. So let's look at the numbers. By the end of last year, I've taken those statistics from the latest report of GSMA. We have that in terms of assigned spectrum for 5G use is we have more than 128 operators that got the license. We are talking about around 40 markets. So you see the frequencies news are basically the three bands. The low band, mid band, high band. So low band, we mean below 3 gigahertz. The mid band means around the or within the C band. So we are around 3.5 gigahertz, and then we have the high band, also denoted as millimeter wave. Practically means above 6 gigahertz, as written here. Below, so you see that the most used band for 5G services is the mid band. Now, in terms of 5G launches and the commercial networks, we are already having more than 111 operators that have either launched or planned to launch this system. Sorry. Let's hope I can speak, because I haven't been really well in the last 4 days. About the ecosystem, I made these slides which capture a few interesting numbers, and the first is the number of connections. As we speak, we have already more than 234 million people connected. That was by the end of last year. And we are expecting to connect 21% of the world by 2025. So this is a massive and unprecedented adoption of a mobile communication technology. Now, looking into the details, I'm sorry, I can't speak. Yeah. Okay. Looking at looking at the details, we have that yeah, more than 600 announced type of devices, and most of them you see from the pie charts are smartphones. So you have a choice of already commercially more than 200 commercially available terminals and many kinds of CPEs for fixed wireless, and then other form factors of end user device available as well. So you may see here more than 30 type of devices, now models for drones, vehicle drones, robots, and specific devices such as laptops and hotspots. Now, looking at the numbers and the global adoption of 5G, we may see from those bar charts that most of the deployed base stations are in China. So if you can compare the two numbers, you can see that China has already 202 millions connections out of 234 millions, and that would be, sorry, there will be more than 800 millions by 2025 out of 1 billions. But it's of course intended that the adoption, it is truly ongoing globally. It's not only about China here. So in percentage, you may see that the North America is currently leading the penetration, and Europe is doing well as well. But we can't complain Asia Pacific because also here where we live, we have a substantial already adoption and usage of 5G services. Yeah, now let's have a look at the 5G and how that will evolve from the standard perspective. And I want to surprise you that the technology are running very, very fast, faster than ever before. So let's look at this chart, which I have right now refreshed. So the new radio, which means the new interface was already finalized in 2017, and then the system was already completely specified in its standalone configuration back in September 2019. Now, if you look at the supported services you're having now in the field, we're already enjoying basically the services on given by the release 15, which is about enhancing our mobile broadband experience. And recently has been also completed the release 16, which is expanding the scope of the supported functionality, and in addition to enhancing further the mobile broadband experience, we are now targeting to deliver services for ultra reliable low latency communications. It is also ongoing now, the specification of the release 17, and release 17 will be focusing especially on the consumer type of IoT. So all these three releases will basically complete and meet all the requirements set back in 2015 by the IEEE as a vision. Now, beyond 2022, we are already speaking about the potential content and new use cases categories of the release 18 and 19. As we speak, there is a massive already research ongoing on 6G. I'm thinking of, in particular, the work ongoing in China, in the EU, but also initiative in the US, And the expectation are that by 2024, in about 3 years from now, 3 to 4 years from now, so very, very close to us, we will start the study items on 6G, and then the technical specification work will start the following year, so 2025, for the commercial launches in 2030. So the scope of my talk, it is a limited to this point. So I will cover all releases down to the 17th. Yeah, perhaps next session I could talk about what comes next. But now let's focus on the 5G or 5.5G. I have made up in a high-level summary of what it's all about. So I'm on this slide. I am covering all features and enhancement of release 15, 16, and 17. By the way, before I forget, narrowband IoT was there already in the past. So I'm thinking of release a 12, 13, enhancement 14, and will continue. So narrowband traffic, so the famous Internet of Things or machine type of communications on LTE will continue regardless the evolution of the new radio. So that has to be crystal clear. So the cellular IoT was there, is there, and will continue regardless the evolution of the new radio. Okay, said this, let us have a look at the new radio specifically. This diagram shows the services provided by the new radio, namely around the eMBB and URLC compare to the narrowband type of communication services that DLT already supports and, as I said, will constantly, continuously enhance. So, release 15 and 16 on the new radio support already spectrum from 400 megahertz to 52.6 gigahertz. This is a fundamental difference between the new radio and the LTE. So this we have to remember. So the LTE has been designed to work in the sub 3 gigahertz. So you have cases like in Philippines, they're pushing up to the C-band, but practically the LTE has been designed with indicated distance of 15 kilohertz only to work in the sub 3 gigahertz. Therefore, the new radio pushes spectrum utilization much farther, and you see here up to the 42.6 gigahertz. Then the release 17 now, the new waveform will be studied and completed so that we can meet the requirements of spectrum up to 71 gigahertz. Now, specifically, what are the differences between these releases with forward capability? So also the new radio has no backwards capability, but has forward capabilities only. Very interesting in that sense. So release 15 came along with an enhanced and soft interface. We're thinking of a possibility of changing the numerology, so that means subcarrier spacing, cycling prefix, the transmission time interval, and so forth. Introduces new coding scheme, supports already a dynamic spectrum sharing. I will present you what it means in practice later when we talk about architecture. Introduces by default massive MIMO, which has been optional in LTE until the coming basically capability in the smartphone. I'm thinking of TM8 and TM9, for example. Passive MIMO is by default there, so it's a feature that you need to have in place to deploy the new radio. Then we have some architecture aspect touched upon later, and introduce also the concept of network slicing. Already end-to-end in theory, they don't give anything specific on the radio access. The radio access will be detailed in is a 17, so it's pretty much left to the vendor specification. So that's pretty much the release 15, and release 15 in particular sets the grounds and the fundamentals in terms of enabling technology and architecture for security controls and assurance of the system. So that's pretty much what we have today in the field. That's pretty much what you are enjoying, and by using the latest terminals. Now, what's coming next? Next is release 16, as I said, completed last year. In terms of specification, it's coming along with the broader aim of covering all industrial IoT type of applications. So you may think of Industry 4.0. It supports the new radio on an unlicensed spectrum, 5 and 6 gigahertz in various configurations, extremely nice, even in standalone configuration. So that means like Wi-Fi, you can have your new radio on the unlicensed spectrum. Position is enhanced, no longer say rely upon the GPS, but there is a triangulation possibility of measuring down to 3 meters will be further enhanced to 30 centimeters. Release 17, so then we will really seriously think of connecting robotic platforms, mobile robotic platform network control, or say teleoperator, which is not possible now because the accuracy, it would be too bad. So it would be like 20 meters. So you can't have a robot that you can maneuver an element with such inaccuracy. Then beyond this, what else we have? Yeah, they introduced the integrated access and backhaul. I will explain you this feature later. Vehicle to X communication and future radio mobile communication system. By the way, just as a parenthesis, the GSMR retires. So all a system in the world are using GSM, talking about the railways, communication has been agreed to be retired by 2030, and it's been also agreed that that will be replaced by the 5G. The 5G new radio is a 15 and 16. So you may think of all the services, mission critical communication, audio, video, augmented and virtual reality also will go to the future MCS running on a 5G system, release 16 and 17. What else is coming? Release 17 is also introducing first time in history the possibility of having NTN. It doesn't mean NTN, non-terrestrial type of accesses. So the satellite systems already agreed to be a GEO and LEO. What they are, I made a node here, so you see the details. But we need to remember here, especially are the connectivity, the access. No, it's not. It's access. So that means it's just it's provide access to the 5G services, augmenting the possibility of reaching out the 5G services not only through the cellular system, so our base station, but also using satellites. That's the fundamental difference, because as a backhauling technologies and relay technology is there already. So we want to see those systems now coming as an access technology. In particular, I think important are the LEO, so low Earth orbiting satellites. They are satellites extremely fast. They can go around the Earth in less than 2 hours. You see here, and the altitude is going to be from 300 to a 1.5 kilometers, and they allow us to extend the coverage massively, where you see here the beam footprint and reduce latency below fiber. So that means if I'm communicating from here, Sydney to New York, it will be faster via satellites than if I, for example, deployed a fiber from Sydney to the ocean down to the Earth. Yes, because the path will be shorter. So beyond this, the release 17 will support BMS, and in particular will enhance the services in the terminal and in the core network, the UPF, user plane function, to support the multi-access edge computing in 5G. And beyond this, we will have a fresh new a protocol stack enhancing vehicle-to-X communication, but also connecting unmanned area systems such as drones. Okay, that's panoramic view of the 5G and its evolution. We go now into the details. First, how will the architecture evolve? The architecture, I mean, realistically speaking, there are many people talking about this. This is my view. So the architecture in reality will evolve as presented on this slide. We are here today. Today you have an LTE system on evolved packet core. That's it, simple. Next step is to launch new radio. New radio will be launched on non-standalone configuration, which means you take a base station. I'll show you what a base station is in a moment. And you just put it, you collocate that, a baseband unit plus an antenna. And then you connect the baseband unit with a cable. Simple. And yeah, in this case, the new radio, your new radio will be only transferring, you see a data plane, it's just a pipe using the core network, nothing else. So the same system, you may clone it. Difference is exactly the same, antenna slightly different. The baseband unit is the same. Same, you put a cable or you can add one card here, depending on the vendor you're dealing with. It doesn't matter. So, and that will work on a secondary barrier split. Signaling will be handled as an anchoring point by the LTE. And this system has to collaborate and coexist for a very, very, very long time. So this is the most important path of the evolution, as most of the carrier, to my knowledge, a few of them are thinking of starting in a overlaying configuration. For example, in China, some of the carriers, they think of doing this, but although requirements are for a standalone configuration, the path builds and will build on LTE. Then, yeah, so that's how it works. And today you are playing with non-standalone UEs in dual connectivity. Dual connectivity means that yeah, the PDCP protocol. So they basically is the layer 3 on top of the MAC layer is split, or the RLC layer is split into two parts, and the splitting is done inside the new radio station so that the terminal can receive data from the new radio and from the LTE station at the same time in a secondary barrier split. Then we've introduced the core network, and what we have here is an NSA-SA standalone fusion, where you have a fresh new system here that will coexist with the existing no standalone configuration. It's a very, very simple. It could be a software upgrade. It depends on the vendor, but the system is extremely simple, that you maintain the ecosystem you have developed already in terms of terminals, and you upgrade your node B, your new radio G node B, so that you can support both the S1 user plane towards the evolved packet core and the 5G and new services, and ultimately all the services will go to the new radio, as all frequency will be ultimately refarmed and supported by the new radio. You remember the spectrum, new radio 400 megahertz up to 72 gigahertz. Yeah, that's the path. Or other operator may say, okay, look, I don't want to do much here, and I'm thinking of overlay my system and only on sporadic areas offer my 5G services to SC terminals. That means you will offer an inter-system handover like we are doing today. You consider the option 1 compared with the UMTS or earlier generation system, you have an inter-system handover. That's pretty much the story. It will take many, many, many years until this path here will be completed, and now I will prove why. Yeah, then looking at the standards, the standard also presents the so-called CODU split or RAN disaggregations and yeah, introduce network slicer, try to understand what is all about why we're doing that, where the potential gains and drawbacks. So let's look at the system first. So the radio access consists of yeah, let me say four, yeah, practically 5 parts. But let's say, let's start from the baseband unit, and let's leave out the antenna and the radio unit. So the baseband unit can be split, separated into 2 parts. So we have the CU, so the central unit, distributed unit. Well, the idea is say, okay, look, I have a protocol stack. I can divide into 2 parts. So say, okay, the one that are slow protocols such as the RRC and this DAP on a PDCP, I can leave them and run them on a cloud platform located potentially centrally. And then the remaining part of the stack, namely the RLC, the radio link control protocol MAC, and a part of the physical layer, I can do that somewhere else. So by doing this, I have some advantages. Okay, I have advantages in terms of higher efficiency because, as you may see here, I have the possibility of, with one control and transport unit, to reach out many more stations. Yeah, but that means I have a higher efficiency, and at the same. But if I am separating the stack in this way, okay, I have the advantage to relax the backhaul the all is called these 2 points. But on the other hand, I am increasing the delay. Yeah. So that means by moving this part of the stack closer to the edge, or push it back to the regional data center, have the possibility of gaining in efficiency or improving the user experience. So that's basically what the poses. And yeah, in addition to this, practically today, most of the configuration are co-located. CUDU are basically in the same rack, same box as the new radio is co-located with the DLT. There is no need of deterring traffic, and therefore there's also no need to increase the complexity and disaggregating the system. Yeah, we can speak one day on this, but I have more things to say, and I'd like to move on now. And what the TGP also introduces is the concept of integrated access and backhaul, which means that I have a base station, which is playing the role of a donor, and it offers the backhauling services using the same interface as the one used for access. And well, that will make my system, say, extremely cheaper and viable in terms of backhauling, because I am using, say, the radio interface with an appropriate distribution of spectrum to backhaul the traffic I may receive when the terminal access different base station. Here you have the interfaces specified by this standard. Now, why we see a potential of disaggregating the RAN, and what is the enabling technology that would allow our deployment network to become easily to be orchestrated. Let's put it this way. It is the network slicing. So if you think of having the possibility of running virtual function, I'm thinking of from the DU down to the okay, IMS, but the core network here. This user plane, control plane, yeah. So if you think of setting up, defining slices, which are virtual different virtual network instances and choose them, aggregate them, or chain them based on the tenant or the service you're going to provide, then it really creating value in having possibility of having in place a disaggregated system so that you may activate those particular functions virtually with different networks depending on the services you intend to provide. They may range from a high reliability voice down to massive type of connectivity, where in the first case you need to reduce latency tremendously. So you have to collocate them, you have no chance. But they're here. At this point in time, you need to aggregate as much as possible the traffic at the regional data center. Therefore, you may think of connecting the split manner because latency is not an issue. Now, two words about security, because the RAN enhances and also the security is further enhanced. Here you have all what happened in release 15, 16, 17. And let's focus on what happened to the radio access. The radio access supported new functionality compared to LTE, and also security assurance requirements and test cases for aiming at potential certification framework. Now, looking a bit into the details, I have borrowed one slide from my friend Rainer of Rudy Schwartz. I've enhanced that by including the AHAMA, the authorization key management for accessing 5G services using 5G keys. But let's focus on that's the end-to-end system. Today we are looking into the RAN. So let's look at the RAN here. So yeah, that is still illustrating the split, pseudo split, and see how 5G works is extremely simple, but extremely secure. It's this most secure system and way of authenticating, authorizing, and encrypting the information. There is no other in the earth better way to achieve this service. So that works well. It works easily with a master share secret key. You may find it in the in the repository of the core network, as well as in the mobile phone. And based on that, all the other keys are produced. In particular, looking at the RAN now, what happened in the RAN is the RAN attains the key for the GNOB, and out of this key, it produces, you may see here the key here, and in particular, we have not only keys for authenticating the traffic, but also for encrypting the traffic. So now the traffic is encrypted. You see at radio interface, both signaling plane and the user plane. In addition to, with respect to LTE, we also have an hash function with a message. So we have an hash function that allows us to provide integrity not only in the control plane, but also in the user plane. So beyond that, I want to say a couple of words about security. If we consider the DUCU split, what the standard says is that and by the way, let me go back between these 2 points. So the phone and the CU, so the age, if you want, of the base station, the traffic is encrypted. The traffic of any kind is encrypted. So I wouldn't spend too much time, but still the standard presents a few requirements. So you happen to further split this unit in the, sorry, this CU, yeah, this is a typo here. Yeah, there should be a CU user plane and CU control plane. Apologies. Yeah, I will correct that later. I need to inform Rainer. Oh, sorry, the European Commission. This is taken from the European Commission, so let me stay easy. Yeah, apologies. Yeah, I didn't, I trusted it was correct. It's incorrect. Yeah, so it's not my fault. So this in this ENISA, European Commission. So this, if you think of separating these two things, you need to encrypt the communication between 2 points using IPsec. Similarly, you need to do that at font C in communication with the DU, and it remains optional as far as the traffic in the user plane. And here I've also added the other way of authorizing and encrypted traffic across the other interfaces, and especially between visual functions in the own network. One word about the NISA scheme, because that's the most important initiative we are having on security assurance on mobile communication system. So there's a lot of discussion around cybersecurity now, and so we do have an industry unified authoritative scheme in place now, defined by the GSMA and the 3GPP, which is called Network Equipment Security Assurance Scheme. S scheme is missing here. Scheme and yeah, consists of 2 parts. We have one part, main contributions from GSMA, defines the auditing tests for auditing both the product creations as well as life cycle of the product entirely, and the process is the second, using the technical specification from 3GPP is about the evaluation of the security specifically of the network equipment. So they have already finalized the test specification. This one will be further enhanced later this year, but basically this is the scheme where all vendors are supporting, and I'm thinking of specifically Ericsson, Nokia, Huawei, ZTE. They have already passed the auditing tests, and Huawei has also managed to pass both auditing for the core network radio access and tests for the radio base stations, 5G and LTE. That was back in December last year. Now, moving forward. Okay, yeah, so now that discussion that this scheme, and I hope will be adopted as an authoritative scheme within a certification framework. That is the discussion we're having now. Germany and member states, but I would say globally. Okay, good. Now let's go into the core of this lecture, and let's start from the deployment criteria. So we need to think of a system that will evolve. Now, if we target a vision of 2025, first thing we need to understand are end user requirements. So the customer's requirements. What kind of services we are expecting? And so I have introduced the concept of EMBB, MMTC, and URLC. We now introduce 3 new usage scenario that we need to support by 2025. So the first is called uplink-centric broadband communication. And that means all the services around smart industry 4.0, I would call. Then we need to meet all the requirements for real-time broadband communication. And here I'm thinking of VR, mixed AR, mixed reality, large screen, 8K, and so forth. And then the third and equally important user scenario wanna meet in terms of performance requirements are harmonized communications and sensing. And that is about the 5G connected UAVs and vehicle 2X communications above layer 3. In terms of scenarios and industry, yeah, the target is to really meet all the requirements for all possible scenarios and absolutely all possible industry. Then you may have a question, say, what do we need 6G for? Because 6G is a completely different aim. Yeah, we talk about that offline. But yeah, in terms of connecting things, we want to make the. So here you have the all possible in a high level scenarios and industry, and the key trends and expected capability in terms of enabling technologies. Let's move on now. If those are the scenarios we want to, yeah, the scenario we want to deal with and provide the 5G services, the question is, how do we achieve this vision in terms of enabling technologies? And we have in the following slides a strategy formulated in terms of deployment criteria, how you're going to use the spectrum, how you will evolve your network architecture, and now you have necessarily the need of simplifying the site, this mess you're having today. Let's start from the criteria. So the technical requirements in terms of performance. Where are we today? Today already we are having excellent performance provided by the release 15. So here you have a summary of the measurements we have made pretty much all over the places, and you may compare the experiences in terms of throughput, what you get from an LTE system, yeah, and what you get if you are enjoying the same type of services. With a new radio, basically, it's at a factor 10 better experience. And now, looking beyond this, this is today. So today, it's a phase 1. We want to achieve a phase 2 by 2025. And we want to have a system that allow our carriers to offer services not only to consumer. So it means not only B2C, but we want to offer service to home and to any business. So I'm mostly interested in a B2B type communication, so thinking of verticals. So that means, in practice, we need a system that evolves in all aspects to meet the requirements supporting this table. So for 2C communication for the consumers, we need to shift, for example, like my son now, gaming, playing is happy with 50 megabit per second downlink, and latency is okay. But later, his expectation will dramatically increase because the frame per second will increase. So the target performance we rise over a factor of 4 in terms of speed and latency reduction. Similarly, you may have other type of requirements for home. Yeah, we have fixed wireless access. We are happy with this, but then we need to reach out at least these speeds, and in particular to provide the services to machines, mobile objects, or robotic platforms. We need to achieve, you see here, requirements not only in terms of latency, speed, but especially in terms of reliability. So from 4.9 to 5.9, I would say even beyond, as already presented you the positioning. If you want to play with the robotic platform, you need to go down to centimeters. Okay, let's go quickly now to the other, actually to the changes we need to have in the system to meet those performance requirements. Spectrum. Yeah, so the spectrum, as I said, is the new radio has to support all spectrum. Yet, the strategy is, as presented on the slide, is to access all spectrum below 100 gigahertz, namely 72 gigahertz. Yes, but what we want to do is to do it properly. and leverage all the capabilities you have in place, especially the coexistence of the LT and the new radio. So we will use 1+N capabilities, which means we need to have a one band, one large band, and N frequency bands that I'm going to use on demand, which means depending on the services I'm going to provide, I can increase the number of supplementary band I'm going to use. And yeah, I'm giving now more details how to do this. So to the C that we dramatically into the C, I will use this term, C consumer, B business, H as home. So C to C, we will have a possibility of increasing the master credit throughput. To B, we will be capable of using supplementary uplink, therefore increase the band with the uplink. But practically what we want to achieve here is that we complete decoupling of the transmission uplink and downlink, so I can have a possibility to generate any kind of throughput. Looking at the deployment scenarios, using these particular configurations, we are practically simply able to provide communication services all over the places. You may have a, let's look at this slide. So yeah, that means if I'm if I find myself to be in the dense and urban area, I have the possibility of exploiting all band practically. You see here, all band. So I will have a central frequency. So a one will be in the C band, and then I can think of hiding the other components. Yes, that will remain my central band. I may think of adding other component too if I'm thinking of outdoor sports. And then, of course, in extreme and long range cell and coverage, I'm thinking of the rural area, then we must use frequencies below 3 gigahertz. So by supporting different type of spectrum, you may see also what kind of services you are able to sustain. For example, in the case you are below 3 gigahertz, the band and the delivery throughput won't be much, but the reliability will be high, so that we may think of a smart factory as well as the basic services. If you want to support higher speed, VR, AR, then you need to have in place more spectrum, which means one will be then complemented by other spectra. So how the network will evolve to support what I've presented earlier. So the first important statement, a key message for me to deliver is that the LTE and the new radio will evolve jointly for a long time, and the new radio is a child that will develop on his mother, that is the LT, and the mom will continue generating services and develop is the capability. So LT will be on the one hand evolve, as I presented earlier, and will be able to deliver gigabit speeds with a massive carrier aggregation, massive MIMO dual band too in FDD, for example. Reduced latency because the slot will reduce on LTE2, enhance this, but and in parallel, the new radio will add more capabilities, reaching out 20+ gigabit per second, millions of connections for square kilometer, and push it down the latency below 1 millisecond, or if you want a one-way 0.5 millisecond. No, how that things will evolve in practice. Let's go a little bit into the detail. So my presentation today is very technical, very detailed. So I hope you won't get bored, but this is how things work. So it's an opportunity for us to enjoy this fantastic technology. So as is, where are we today? Today we are here. We have a system that in many bands available. So there's the sub 1 gigahertz, sub 3 gigahertz, and the C-band. And the next step for us is to, yeah, they're already working together, but basically the new radio is separated from the communication you may get through the LTE. What I want to do here is to have the possibility of enjoying spectra by sharing the spectrum between technology and up to the limit where I have enough traffic on the new radio and no traffic on the LTE that I'm saying, okay, let me reform it. So that is fine. But this transition has to be smoothly handled as I presented on these slides using different color. And what kind of technology may I use at different frequencies to provide LTE and new radio services at different carrier frequency. So we shift from 44R, so for transmitter for receiver, to massive MIMO configuration. So in particular, how the system evolves in practice. So we initially always think of providing coverage. Coverage is a fundamental coverage. And the first configuration that is in place is a 44R, and 44R basically enhances the current deployed configuration from 2T2R to 44R, improving the experience of the user at the cell edge. The capacity will be in turn enhanced by introducing the dual band AT8R, which also may support the beamforming. And there is a massive availability now of TM8, I would say TM9, TM9 smartphones that support beamforming, and that would allow us to enhance capacity with respect to the ALS configuration, or offer that on top, depending on the system deployment. And then we may reach out the extreme capacity using 32R or up to 64R massive MIMO. And yeah, that's one thing. The other thing is to exploit the possibility of working in dual connectivity, as I mentioned earlier. So that means instead of using the communication from the LTE station and have overlaid this with a new radio, you see here, new radios in a standalone configuration running parallel to an LTE configuration. What we should do instead is to think of make them work together and exploit as much as possible the dual connectivity. So you may have two configurations here as an example of dual connectivity. You may compare the experience, how they would improve with LTE. It is basically working in dual connectivity with the new radio, with a one fundamental carrier, and using the LTE and aggregating the remaining part of the spectrum. Yeah, that would be, say, in the sub-3 gigahertz, and even better, much better performance can be attained in the C-band by aggregating the spectrum on LTE at the lower frequency. Also, using dual connectivity, it is possible to smooth out potential coverage gaps while moving from one area to another. So there is no handover. It's just a way of adding branches in the communication. The other possibility is to aggregate and integrate actually in the in the system multiple bands, and use them at the same time, allowing the scheduler to access all this capacity without carrier aggregation. And that is possible already on LTE. So the next step from last year, we have the possibility of having the concept super band running on LTE and the new radio together, and that would basically allow us to boost the capacity. Another important feature already available and further enhanced as with latest 2GPP releases is the so-called dynamic spectrum sharing. So that allow us to, if you look at here, it's I have a spectrum currently all allocated to LTE. Is now possible to share that particular band with the new radio, and different possibility of doing that. And here you have an example of sharing an equal band between the two technology. You may say, okay, look, I want to reserve a part of the capacity to my new radio phone. That's how we share. So there are benefits, as you see here, while doing that in terms of carrier aggregation compared to the EN. So that means, say, in dual connectivity, or reaching out the complete refarm. If I could, remember, I should avoid using the dynamic spectrum sharing. If I knew exactly how the traffic works, develops, because it's a lot of overhead in place. If you look at the details of the radio frames and the radio blocks, because we are forcing now the new radio to invade the LTE transmission. So ideally, I should be able to refarm, and the maximum benefit you see here will be when exactly the ecosystem will be such that I can refarm and using the frequency with the new radio. In the uplink, 5G allows, the new radio allows a complete decoupling of transmission in uplink and downlink. As you know, when the frequency is very high, we need to go to TDD. So I either speak or I listen at the same frequency. You see here, easy. Yeah, that's gonna work. Or frequency and C band and above. Below, we may think of FDD. So that means we can transmit simultaneously by using the difference. Now, if I can split the two-mode transmission, in particular, exploit the LTE uplink, I have a possibility of maintaining my coverage. Like in this case, where we have the possibility of using the uplink and downlink decoupling, that the communication will remain in place in the uplink using the LTE communication. The uplink you see here, where there is no more possibility to reach out to base station TDD, or may simply make them work together. Let's say I do want, they must work together. So that means this communication will be always in place, and then it's up to me to decide, base station, to decide when to enable it. So that means when I'm located here, that I have full coverage, TDD. I will work both in TDD and the supplementary uplink. Then when I'm leaving this area where the uplink is a challenge to reach out in TDD, I stop basically at transmitting from the mobile in that mode, and I'm continuing my communication using the supplementary uplink spectrum. Here you may see the measured gains we have found. And then we may think of leaving that as such, so that it's always in place. And if you think of, for example, of connecting machines, where the uplink is really an issue like drones, then you may leave your supplementary uplink communication always in a place using the new radio way of transmitting. Okay, when we think of evolving the system, the simple way of doing that is to share the network resources. And here you have three distinct scenarios from left to right. Okay, the simple way of supporting different services is to use quality of service. So this concept has been there for many years. It is still valid using the new radio, and here the granularity is at flow level, the 5QI. So using different 5QI, I can simply handle different type of traffic, and my scheduler can provide different experiences depending on the weight I'm setting to B or to C. The other possibility that the new radio allows me is to reserve a complete radio bearer. So you have different physical radio blocks that I may decide to completely devote, reserve for the to be type of traffic. And in this case, for example, I may reserve my resources, physical resources for to be users. At the same time, I may introduce a dedicated multi-access computing platform so that I am at the same time not only improving the speed, but also reducing the latency. And the last thing I could do is to think of a dedicated a private network, so I can have two different carriers. One carrier goes to consumers. The other one may go completely to B, and together with not only the MAC and a user plane function, but also you may have signaling capabilities. So that slides summarizes pretty much what I presented and shows a division of 2025 entirely with a fully distributed network with different type of capabilities and architectures and compositions of the way the end user may access the network in a flexible, I would say, efficient and effective manner, depending on the corresponding end user requirement. Then we need to have a full mesh, say, aggregation and backhaul, yeah, we need a full mesh aggregation that would allow us to efficiently handle the communication between the different data centers where the core network functions and other functions, including the IMS type applications, are located. Okay, now let us have a look at, before concluding this presentation, about the site. So physically, how will that evolve? And then I have just a couple of slides on AI-enabled automation and security controls, which I've been speaking a lot. So there is a lot of material in internet available to this. So I just mentioned this, but now the focus is, let us have a look at seriously how the site will evolve. And we start from antennas. So the antennas, today we are here. It's a mess. Yeah, it is a, it's not only a not good looking, say, view, but say, it consumes energy, space, it's a cost, pollutes, and yeah, so we need to move out from here, as we need to reduce the number of radio units, and we need to get rid of all the cabinets. So that's the target here. We want to have a clean performing site that supports all spectra, and with the possibility of keeping our LTE coexisting with the new radio. So today, end of this year, we are here. So the first thing we do is to, so we are here, see the mass, this mass. So we move towards a one passive antenna. So all the sub 3 gigahertz band represent will go here. So that means GSM, UMTS, LTE. You put all them here. Yeah, one band. Plus you will add a new radio. New radio, maximum configuration, could be of any, like 32T, 32R, 64T, 64R, very easily like this. Then we may think of combining them so that we can place them theoretically within the same radome. The lower part will be basically incorporating those antennas, and the upper part will be about the massive MIMO. So the ultimate goal by 2025 is to have the possibility of accessing two distinct type of configuration. So we either keep the communication split as presented above, or we may think of consolidating them into one single radome. One single radome that will be denoted as blade active antenna unit, which will consist of 2 active antennas and 1 passive antenna. Namely, the upper part will have 2 active, it's a dual mode, 2 active TDD communications and a multi-band, dual band FTDD, a massive MIMO. And the lower part will run the sub 1 gigahertz passive antennas. How we get there? Easily. The way is to look at this particular implementation. We just use the see-through technologies, because you may think of a place behind the radiating elements at 7, 8, and 900 megahertz, our array antenna that will radiate at higher frequencies, and basically there is no interference between the two communication system. Looking at the detail, the passive part will be supporting a 88R communication, including beamforming, and then 44R in the Lima band, and then for the 44R also available for the sub 1 gigahertz. And the active, sorry, this is not massive MIMO, not beamforming, apologies. So there is no active antenna here. And the other one, it will be about the active antenna that will be in a configuration up to 64 T64 are in the C band with an instant bandwidth of 200 megahertz and occupied bandwidth too, and an extremely very high power. And this is already pretty much what happened in Switzerland, for example, the deployment. Then, so that's the antenna, how the antenna will evolve. The RRU, so the remote radio unit, If you remember in the past, when I was in Finland, that was plugged into the cabinet of the base stations, and then you had the feeders, long cable, long feeders to reach out antennas. So we decided to take it out. So now you have a CPRI interface here, and then you have the cables to plug into the antenna. So therefore, the losses due to these feeders is reduced. But still, if you look at the commercial offering, you need to have one of these boxes for each of the supported frequencies. So the target now is to have a triple band RRU that supports up to 44R. So a one box that I could place on one pole, reaching out the concept of the Blade Pro Ultra Wideband RRU 321. So practically, we have achieved the possibility of getting rid of the so many antennas. So passive active antenna go into one blade active antenna unit, which is integrated, by the way, using a blade microwave configuration, which I'm not covering today, how that works. It's easy, E-band, and then in the classical band, possibly combine all of them into one antenna system. Then we have managed to get rid of all those boxes. That means all the RRUs in the sub 1 gigahertz and sub 3 gigahertz, and place them in configuration of triple dual bands. And then finally, what we also managed to do is to have consolidated BBU, so a one BBU baseband unit for all the system above, whether this is a passive radiations or it is an active antenna element. And in particular, we have also considered the power and the batteries, and so we have got rid of all this mess on site. It's all on one pole. And by the way, in addition to having the possibility, as I presented earlier, to handle the spectrum efficiently between the different modes of transmissions, thinking of the way you may play with the LTE communications and new radio and the supplementary uplink, but also supplementary downlink, we have managed to orchestrate the power, because now with the blade power unit, we may think of handling properly and aggregating the power or the energy transmission to the different elements, and therefore save energy. And the total TCO saving today reaches out up to 65%, and the time to deploy a base station to build up a site reduces from more than a week to less than 1 day, and only a few people can do it because it's all light stuff that doesn't require much work. Finally, let me say something. I know it's probably we're over time. Yeah, I'm sorry, but it's curious, interesting to see what happened. The millimeter band, and in particular, I want to talk about the indoor communications.
David, do carry
yes.
on. Do carry on, because your presentation is very interesting.
Okay, thank you. So yeah, let us look at now the millimeter wave and how we're going to use them. Yeah. So first, the millimeter wave is a dedicated, specific, localized deployment. You cannot think of covering Australia using the spectrum or other countries. So it's really a specific hotspots, and it really boosts the end user experience. So these are the measurements we have made in Chengdu. And you may see here that the experience easily reach out at 3.5 gigabit per second. If you may think of using a carrier frequency, for example, 28 gigahertz, 26 in Australia, there could be Europe equivalently, and the bandwidth of transmission is 800 megahertz. So that's basically the experience have 3 to 5 times better than playing, say, at a lower frequency, or even thinking of aggregating them or integrating them, or different dual connectivity, anything you may think of. And yeah, here you have the tail numbers, and in particular, the configuration we're having now in place. It is a very, the highest effective isotopic related power up to 70 dm, and in particular, this configuration is 88R with a carrier component of 400. Yeah, fantastic. So in terms of capacity, we have a boost of up to 90% as a peak, in terms of peak throughput, and average, yeah, the increase of plus 20% compared to the 44R at the same carrier. Yeah, indoor. Indoor is extremely simple, and in particular, by playing with Pico RRU, I explain you what I mean now. It's very easy, nothing to understand, by the way. It all works in the same way. One BBU, and you just plug it, and everything works. We may already exploit the possibility of having in place distributed massive MIMO, which means allowing the terminal to receive and transmit with multiple through multiple beams simultaneously. How does the system work? So we have the BBU, which I have presented earlier, Baseband Unit. Yeah, I presented also the this is co-located. CU, DUR functionality are all in here, and it's multi-mode everything. So you just plug this to a radio hub. A radio hub is it just reproduce this CPRI interface, nothing else. And what it does then, it allows us to connect a number of Pico RRU these are pico RRUs, you see here, small RRUs, and the connections here also carries both. It carries the data using an eCPRA, eCPRA type of communication. And then also, on optical, and then it also carries an electrical cable, so that this hybrid cable, it carries the power. So you don't need to, to have a, and then you need to distribute them. So that's one block, and then you may think of installing them on different floors, and you need to avoid the interference, because it's just one cell. You're just extending, if you allow me brutally saying, the antenna size that you can distribute it, okay, all over the places. And here you have the configuration supported mode. It's basically pretty much all around the BBU that supports all modes, and then you have the possibility of transmitting and splitting over 40 and receiving on a for a receiver. Here you have the different band and combinations, but practically what you can do here is to make your new radio work with the earlier generation system, therefore support any kinds of ecosystem you are having in your indoor scenario. Now the question is, okay, fantastic, but we do have interference. Yes, so what should we do? Yeah, then we can think of a beamforming configuration. So to use that box, the PQRU, to form beams, and the configuration we are talking about now, it is a 44R cell that supports beamforming and allow us to support also distributed beamforming if you want to distribute it maximum. In this case, you may see that we may shift for 44R single user MIMO with the 1, 2, 3, 4 layers and 2 layers in the uplink to a multi-user MIMO with a 16 layers, 8 layers in up. Perfect. And this is what we need, because indoor is where the coverage is needed, and you may be in trouble in this, using the C-band to penetrate walls millimeter wave. You may forget about this. Yeah, so you will have troubles to, although you have a massive MIMO 6040 64, I think you have trouble to illuminate. Think of Sydney, illuminate the different buildings. You need to have an indoor small cells type of deployment, and we have also an equivalent configuration for the pole. This is a lamp site, and we also have a pole site configuration, which also support the integrated access and backhaul. So that means with a donor cell, you can easily cover all floors and all city by interconnecting them using integrated access and backhaul simultaneously, especially viable now that the traffic is not much. Okay, that basically concludes my speech. I have something, 2 slides on artificial intelligence and security control. So we speak a lot about artificial intelligence, and the answer is yes. We need to talk separately about this. All the system comes along with the possibility of using AI to improve the performance, reduce costs. Practically means reduce the operation, the expense, OPEX and CAPEX. The approach has to be scenario oriented. You can't solve all problems, and follow a specific roadmap across the different levels of automation. So today, or last year and the year earlier, we are pretty much doing everything manual. That is, from looking into the alarms, setting the parameters, and then also make all the measurements, including drive tests, by the way. And today we would like to implement to support the additional features. And here you have example where the problem has been solved. So we are now already able to correlate alarms with AI, and then we can optimize the number of parameters simultaneously. And yeah, and then later from this year onwards, we will enhance those functionality, and the ultimate goal has been for a long time, by the way, but I think now the system has, we do have the technologies and the capabilities of computing at the edge, in the device, at the edge data center, that we will ultimately achieve and realize our vision of fault self-healing and prediction, as well as SLA optimization and automation. I'm thinking of slicing and all the issue you may have in the visualization, especially if you are using containers. Yeah, about security, and here I finished today. Security, there's a lot of debates, a lot of discussions, and a lot of pressures, especially on vendors. And I would like to conclude today to say, okay, vendors, do your work, but you're not the only one really responsible here. Achieve this goal, I think it is a common effort that ranges from standards, service provider, operators, vendor, government, regulators. So the standard organization and the vendors are responsible for the equipment and the device security here and here. Operators, so vendor must comply with the NESAS scheme in terms of auditing. So you need to show me how you produce your element and the life cycle processes you're having in place. Then you need to allow me to test your equipment and show, prove, demonstrate they meet the SCAS specifications. The operator is responsible for the network resilience, operation security. Yeah, network resilience. So it's it doesn't matter if I give you a perfect, if you forget, activate the vision the keys, the security keys, or activate the encryption. So yeah, it's a very strong responsibility. And application providers, so the one on top, they are responsible end-to-end. So anyway, the mechanism.
Hi, David, could you just keep the mic, please keep the mic close to you. Yeah.
Okay, I've anyway about finished. And then, of course, we have a fundamental role of the government, regulators, and the security agency. So what we need to have in place are the appropriate laws, regulations, and in particular, I think we need to have in place conformance programs and schemes through which we may authorize security in the country. And then, of course, it's a closed loop that, yeah, we need to work together and then make the measurements and take the necessary actions then to fix potential problems. By the way, as we speak today, there's no attack vectors on 5G. They're just speculation talks, but practically no attack vectors as there are no incidents. Yeah, and today I'm concluding with simple recommendations to all stakeholders, the ones attending this lecture now, and the one will have a chance to watch it offline as it's being recorded, is that, yeah, I'm inviting you all to adopt and not only to contribute, so to be you yourself an integral part of the NESAS, so the Network Equipment Security Assurance Scheme, as it is the only scheme customized, authoritative, really unified, efficient, and evolving with the technology and meeting all requirements of the mobile industry. There are no other way for controlling and assuring security of mobile systems. I'm thinking of 5G in particular. And yeah, so practically means that the industry players, the government, and security agencies like the Australia Cybersecurity Center in Australia, or the CSA in Singapore, just to mention a few of them, the one I'm dealing with, most regulators are therefore recommended to adopt this GSMA scheme for testing and evaluating all technical equipment. So the ultimate goal is that the NSAS could be truly, really a part of a certification and accreditation process against a predetermined set of security standards and policies for security authorization. That's key word. Security authorization in a particular country. With that, I've finished, and I don't know, Sandy, if there are any questions. Otherwise, we could close it here. Thank you.
Yeah, I think there is one question in the question and answer panel. So I think the question is from Ashutosh. And